Okay, good afternoon. Welcome to my class. Today's topic is periodic properties. We'll learn today melting point, boiling point, atomic radius, ionic radius, valency, ionization potential, electronegativity, and metallic properties. These things. Okay, this at first look. This is the periodic table. Periodic table, you know these things: group 1, group 2, group 3, 4, 5, 6, 7, 8, or also 13, 14, 15, 16, 17, 18. D block, F block elements. Periodic property definition also, you know, the properties which are directly or indirectly related to their electronic configuration and show gradual change when moved from left to right in a period or from top to bottom in a group are called periodic properties. Periodic properties are some chemical properties that exhibit periodicity, are electronic configuration, ionization energy, electron affinity, electronegativity, metallic character, nature of oxide, oxidation state, reducing character, etc. are periodic properties. Look, this ionization energy. Ionization energy from in a period, ionization energy in a period from left to right, ionization energy increases. Electron affinity in a period from left to right increases. Atomic radius from top to bottom increases. Atomic radius from top to bottom increases. Non-metallic character from here to from left to right, the top from left, bottom left to top right, atomic non-metallic character increases, and from right to left in the bottom, metallic character increases. Atomic radius from right to left increases. Atomic radius increases. Okay, this is the electron affinity. Electronic affinity from in the group bottom to top increases. Ionization energy bottom to top increases. So today's main point is melting points and boiling points. You know this definition, what is melting point and boiling point. What is melting point? What is melting point? Okay, the melting point is a temperature. The temperature at which a substance starts melt, overcoming the pressure of the region of a area. This is called melting point of this substance of that area. Okay, this melting point that is a temperature at which one substance starts to melt, solid to liquid becomes, overcoming the pressure of the region. So melting point and boiling point also, this temperature the at which liquid start to boil, this temperature is called boiling points. Okay, this is the melting points of group 1. Group 1 elements melting points and boiling points. This is given is the Kelvin temperature is given. Group 1 metals: lithium, sodium, potassium, rubidium, cesium. This is melting point increases lithium, sodium, potassium, rubidium, cesium, melting point increases. Also boiling point also increases, like lithium, sodium in a group. What happened this group? Here lithium is more most melting point, then sodium, then potassium, then rubidium, cesium. Lithium is smaller size, but then sodium, then sodium is smaller size, there's potassium, then rubidium. This is the boiling point and melting point range. This the at first is lithium in group 1, then sodium, potassium, rubidium, okay, cesium. So the most melting point is lithium. Lithium is more melting point than sodium. Sodium is more melting point than potassium. So group 1 is melting point increases. How increases? From top to bottom or bottom to top? Group 1 melting point. Melting point how changes in group 1? This is top to bottom increases or bottom to top increases. How boiling point and melting point changes in group 1? Hello?
Top to bottom increase.
No. Bottom to top. Bottom to top. Hey, have you seen this is bottom to top? Rubidium, potassium, sodium. This the lithium is most boiling point, then sodium. Look, this is shown is this graph. Look, melting points. Have you seen this group 1, this alkali metals? Lithium melting point is 454 Kelvin, then sodium 371, then potassium 336, then rubidium 312, then cesium 302. Boiling point 1615, 1156, 1032, 961, here 944. So from top to bottom to top, melting point increases. Lithium is smaller size but more melting point, most melting point. How this? Have you seen this thing? Melting point increases from. So what is the reason this for it? Lithium atom, have you seen this? Lithium atom is most melting point. Okay, lithium is more melting point than sodium. Sodium is more melting point than potassium. Potassium is more melting point than rubidium. So smaller size. Lithium atom is its ionic size are smaller. Hence, ionic charge density is high. Ionic charge density is high. The attraction between the charge and free electrons is so strong that the atoms remain strongly bound. As a result, the melting point and boiling point are higher. Because small size, high charge density. Small size, high charge density. For these reasons, the attraction between charge and free electrons are so strong, and they are remain strongly bound. As a result, the melting point and boiling point are higher. Have you understood why lithium is small size but more melting point than sodium? Why? Hello student, are you listening me? No, tara konoটা নাই নাকি না? Okay, hello. Why lithium is more
Yes, sir.
why lithium is more melting point than sodium? It is atomic number is more. With increasing atomic number, melting point should be increased. But here not increases. But it is lithium is more melting point than sodium. But at mass number is sodium is more than lithium. So lithium should be more melting point, but it is less melting point because it's smaller size. Lithium is smaller size than sodium. It has more charge density. So more charge density means attraction between charge and free electron is more. So they are high bound, strongly bound. So as a attraction, so high melting point and boiling points. So like this. Also, they look this element in group 2 elements. Also these things from bottom to top melting point increases. Beryllium, magnesium, calcium, strontium, barium, radium. Have you seen this thing? At the top, beryllium is more melting point than magnesium. Magnesium is more. Here is the exception. Look, there is a magnesium and calcium. There is exception. This year increase, increase, then decrease, then increase, then gradually decreases. Calcium increases. Yeah, should decrease, but calcium, why? Because here electron is filled maybe. What is this electronic configuration? Calcium to 22, 20, you know, this argon then 1s2 4s2 okay. Look at some elements here. Okay, this group 17. Look, here is vice versa. Melting point and boiling point increase down. Okay, this reverse for group 17. We have seen the from top to bottom to top melting point and boiling point increases, but here top to bottom melting point increases, melting point and boiling point increases. Like fluorine minus 220, minus 101, minus 7.2, then 114, 302. So here melting point and boiling point from top to bottom increases for group 17. It is exception. The boiling point and melting points of these elements group 17 show successive increase from top to bottom. This element of group 17 don't have any free electrons. Don't have any free electrons, so can't bond like metallic bond. They don't form metallic bond. So here is only bond is there is no metallic bond. So it form a covalent bond. Intermolecular forces. So we know this intermolecular forces increases with increasing atomic number. You know, this atomic number increases from top to bottom. Atomic mass increases, so intermolecular forces more, so melting point is more. There is no, here is no action metallic character because there is no free electron for group 17. Have you seen, are you listening me? Hello student, why group 17?
Yes, sir.
Why group 17 elements? We have seen this group 1 and group 2 from bottom to top, metallic melting point and boiling point increases, but in group 17 we have seen melting point and boiling point increases from bottom to top decreases, but top to bottom increases. Why? Here this smaller size in group 1 this elements smaller size, so high charge density, so there is a free electron in group 1 group 2 elements there, so high charge density. Lithium has more charge density than sodium, so charge density more and free electrons are strongly bound, so attraction force is more, attraction force needed to overcome bond, so more melting point and boiling point, like this alkali earth metal, but all other metals. But in the group 17 elements it's reverse, melting point is not increases from bottom to top, but in group 17 melting point is increases from top to bottom, because there is no free electron. Fluorine, chlorine, bromine, iodine, they are remain in the diatomic. Chlorine 2, Cl2, bromine 2, iodine 2, they are diatomic. There is no electron, free electron is removed, so there is no free electron, so there is no metallic bonding is possible in fluorine. Here is only one force is remain, intermolecular attraction force. Intermolecular attraction force increase with atomic mass. Fluorine to astatine, intermolecular force, intermolecular atomic mass increases, so intermolecular attraction force increases for these regions from top to bottom. In group 17 melting point, boiling point increases. Now atomic size, what will be the atomic size element? Okay, this, what is atomic size? Atomic radius is defined as the distance between the nucleus and outermost shell. Atomic radius. So we have already learned two periodic properties, melting point and boiling points. Now we learn atomic radius. Atomic radius is defined as the distance between the nucleus and the outermost shell. So what will be the atomic radius? Trend, what will be trend for atomic radius for group 1? Say your reasoning, use your intelligence, say what will be atomic radius trend in group 1? In a group, what will be atomic radius? Hello students, say what will be trend atomic radius? Atomic size or radius? Hello? Hello? Maria, take in screenshot. Okay, what will be atomic size or radius trend? Adil below. What will be trend for atomic size and radius in group 1? Hello? Hello, are you listening me? What will be trend atomic size or radius in a group? Abir, say Abir Ahmed. Abir, rule number 6. Rule number 6 say what will be trend?
Janina sir.
Kano? আচ্ছা এখানে লিথিয়াম how many shell? আচ্ছা এটা পারতেছ না দেখো do you know what is atomic number lithium?
দুইটা স্যার
হিলিয়ামের 2 লিথিয়ামের 3 সোডিয়ামের কত সোডিয়াম hydrogen is 1 hydrogen group 1 elements 1 atomic number so shell 1 shell will be hydrogen. Okay, this nucleus 1 electrons and then lithium 3 electrons shell one electrons in inner shell and then sodium 11 electron. Now this nucleus 1 2 electrons 3 electrons. Look, this is group 1 elements hydrogen lithium sodium and potassium also 4 shell 5 shell. This shell number is increases from top to bottom. Have you seen? So what will be atomic size change in group? Atomic radius or size, what will be changes? What will be trend? Increases or decreases from top to bottom? What will be changed from top to bottom? Atomic size increases or decreases? Adil below, what will be changed atomic radius from top to bottom?
Increases.
Yes, why?
Atomic number increases.
Atomic number increases, also shell number increases. If you down from hydrogen has 1 shell, lithium you say 2 shell, sodium is 3 shell. So new orbit is increases. Shell number increases from shell number
increases.
So shell number increases from when we go from top to bottom, shell number increases, so atomic sizes increases. Okay, what will be trend in the across the period like lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. These all elements have shell number is 2. This period 1 shell number is 1. Shell number hydrogen and helium only one shell. Lithium, beryllium, boron, carbon, oxygen, fluorine, neon, they have 2 shell. Like sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, they are 3 shell. But so what will be trend? Their shell number is remains same. Shell number remains same. But here from left to right, atomic number, electron number is here 1, here electron number 2 becomes 3. Electron number increases. So as electron number increases, so more attraction force. So it is 1 electron. I am doing this. They have how many shell number for lithium and beryllium? Can you say? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. How many shell of these elements? তোমরা কি ক্লাস বুঝতেছো নি কয়টা শেল আছে এগুলো যেহেতু এরা পিরিয়ড 2 as they are period 2 so they have shell number 2 they are period 3 like sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon they have period 3 so shell number 3 this lithium and beryllium shell number is this 3 and 4 shell number is remains same. This 2 shell boron. I am showing these things. Lithium for lithium I only write shell number 2 shell. Lithium, then beryllium, then boron. Lithium, we know this lithium is how many electron? 3 electron. So it is electronic configuration 2 and 1. Beryllium 4 electrons. So its electronic configuration is 2 2. And boron 5 electrons. So it is 2 and 3. So here 2 electrons and 1 electrons. Beryllium 2 electrons, 2 electrons. Here boron 2 electrons, 3 electrons. So we have seen this electron number increases. So here is a electron number from left to right. Shell number remains same. But electron number increases. Here is the 1 electron in the outermost shell. Here 2 electron in the outermost shell. Here 3 electron in the outermost shell. So attraction force between nucleus, positively nucleus or electron increases. Here 3 electrons, more attraction from nucleus and electrons. So attraction force increases. So here attraction force increases, so more attraction, so compact size decreases. So size decreases from left to right. Size decreases, atomic size decreases. So atomic size increases in a from right to left. Atomic side increases from right to left in a period. Have you understood? So I have shown these things. Atomic radius, this from right to left, atomic radius increases. Why left to right atomic radius decreases? Why? I have already explained. Atomic radius from top to bottom increases because shell number increases. Here from left to right atomic radius decreases because shell number remains same, but electron added, more electron added, more attraction, so more attraction, so side decreases, compact become. For this reasons atomic side decreases from left to right but increases from right to left. Atomic radius increases. So I have explained today two topics: atomic radius and melting point and boiling points, periodic properties. Okay student, thank you for joining today's class. Next class I will explain which things topics. Next class I will explain your ionization potential, electronegativity, metallic properties. These topics I will explain. I will give assignment also today. Okay, thank you for joining today's class. Have you any questions?